welcome to Momentum and Vedantu. Welcome. Today afternoon, we are finally doing 5 advanced level questions on a topic that I have taught you guys. Okay, it's 5 advanced level questions on topic that I have taught you guys. And here's the thing: I'm going to try and solve questions from the things that I have already solved, and not from the things that are still going to happen. Okay, thermodynamics we have just started, guys, so we will finish it in some time. Right now, we will focus on doing the questions based on the topics we have already learned. Okay, so Esha Biswas, fandom fighting, Surinder is always here, and Spaceman is also here. Superb, superb, superb. How is everybody doing, guys? How is everybody doing? Did you guys see today's Google Doodle? Yeah? Did you guys see today's Google Doodle? You know who she was? The lady Aarti Shah. Aarti Shah. Do you guys know who she was? No? Atisha guys was the first woman, Asian woman at least, to cross the English Channel. Okay, 36 kilometers swim kiya tha unhone. She got the Bharat Ratna for it. Yeah, super lady, super lady. My chat is never getting refreshed when I want it to. For some reason, let me just make sure that I do it properly. 1 second. Yeah, okay, finally. Yeah, now. Padma Shri, Padma Shri, Padma Shri. Bharat Ratna nahi mila, Padma Shri mila. Okay, alright, yeah. Hi, Himanshu Yadav, superb. Himanshu Yadav knows first woman in 1960. Oh, first woman. Wow. Varun Shastri is anticipating for SAT tips. Hi, Varun Shastri. Hi. Superb. um, well, Spaceman, yes, we will try to plan something for that. Okay, we haven't thought about it yet, but we will do that. We'll work around on that. Okay. Hi, Skadoosh. Glad to see you too, man. Glad to see you too. So, welcome to this channel, guys. If you're here for the first time, please like, share, and subscribe to our channel. I think most of you who are here have already liked, shared, and subscribed to our channel. So, let's start today's lecture. Okay, let's start today's lecture. We are going to talk about 5 advanced level questions, guys. Five on thermal physics. Okay, so now first question might not seem an advanced level question. Okay, the first question might not seem an advanced level question, but this question has come in advanced test before. Okay, this question has come in advanced test before. It's an easy question, one of those easy questions that you find in advanced test. This is one of these. Okay, so yeah. Oh, Suyesh Prabhu Desai, definitely you can try 11th in KVPY. You would benefit a lot to giving that answer. Okay. All right. Himanshu is asking which IIT I am from. Himanshu, I am from Kanpur. Yeah, Kanpur. Okay. All right. Yeah. Okay. Are yaar, SAT tips. Varun Shastri ke SAT tips. Varun Shastri or SAT tips are coming, man. Pakka. Okay. Anyways, SAT tips. I will get onto it, but before that, let's talk about question number one, and that is what I if I have two rectangular blocks, okay, having identical dimensions, I can arrange them in the configuration 1 or 2. Their conductivities are K and 2K. That is very simple. That is given in the question only. Okay. And that is given in the diagram only. And it takes 9 seconds to transfer a certain amount of heat from hot end to the cold end in configuration 1. So here, guys, to transfer a heat of Q, it takes time of 9 seconds. Okay, here in this configuration, to transfer a heat of Q, it takes 9 seconds. Okay, let's say this one is kept at higher temperature, this one is kept at lower temperature. In that case, it is taking 9 seconds. Hi Shri Lokesha, hi Tirupati. Okay, now this is just the first question, guys. If you've just been here, this is just the first question. And in the second case, the same amount of heat, you have to calculate how much time will that take. Okay, and once again we will assume that the temperature is just higher and lower, TH and TL, in the second case as well. So how do we solve this, guys? How do we solve this? So for this, you have to remember a simple formula. What simple formula you have to remember? You have hi Chintu. You have to remember a very simple formula, guys, which is that V is equal to IR. In this case, though, we don't have potential difference. In this case, what do we have? We have a temperature difference. So essentially what you will remember is that the temperature difference will be equal to H into R, which will be equal to H into R. Okay, now what exactly is H here? H is heat current. Okay, if Q amount of heat passes in 9 seconds, then in first case the heat current is going to be Q divided by 9. Similarly, let's say in the second case Q amount of heat passes in T dash seconds, then in the second case the heat current is going to be Q divided by T dash. Okay, so I can write for the first case TH minus TL is equal to Q by 9, Q by not R, Q by 9 into R in the first case. Now, what will be R in the first case, guys? What will be R in the first case? So now in the first case, if you see, both the blocks will have resistances L by Ka and L by 2 Ka. So the total resistance will just be R1 plus R2. Okay, and in the second case, the total resistance will just be R1 R2 upon R1 plus R2. Okay, where if you guys know what R1 is and what R2 is, R1 and R2 will individually have value L by Ka and L by 2 Ka. These are thermal resistances. Okay, so this will be R1 plus R2 in the first case. In the second case, I can write TH minus TL is equal to Q by 9 into R1 R2, sorry, not Q by 9, not Q by 9, not Q by 9, Q by T dash into Q by T dash into R1 R2 upon R1 plus R2. I hope you guys can see. Hi Mahipal. Hi Abhyuday is also here. Superb guys. Superb. I hope you can see this question. I hope you can feel this question. This is for the first case. The first equation is for the first case and the second equation is for the second case. Now what do you do from this, guys? What do you do from this? You just equate the RHS of both equations. You just equate the RHS of both equations. When you do that, what do you get? You get something like this. Okay, one second, let me just write this down. So when you equate the RHS of both equations, you get q by 9 into L by Ka plus L by 2 Ka is equal to q by T dash into L by Ka times L by 2 Ka upon L by Ka plus L by 2 Ka. Okay, now you just have to focus on solving this equation. If you look at this equation, Q will get cancelled out. Then if you see one L also gets, you know what? I will cancel that out in some time. So what I get is very simple. What I get is, if I simplify this, guys, oh my god, simplification is going to take some time, but that is all what we are about here. So if we simplify this, try to do that on your own. When you do that, what you get is 1 by 9 into 3L by 2Ka is equal to 1 by T dash into L square by 2K square A square upon 2L by 3Ka. Sorry, not 2L by 3Ka, 3L by 2Ka. Okay, now situation is very simple. Now this situation is very simple. Very simple. Varun Shastri, yeah, it is the heat chapter. It is the heat chapter, but heat chapter has very similar formulas compared to the current electricity chapter. Now, if you see LKA gets cancelled out, and the other LKA that gets cancelled out with what is there in the denominator. Okay, now things become super simple. Now you can solve them. Okay, it becomes, oh my god, I am not very good at this part, which is solving the equations, but it will become 3 by 18 is equal to 1 by T dash into this 2 and 2 will also get cancelled out. So just 3 will remain. Just 3 will remain. Okay, which gives me t dash is equal to 18 divided by 3 into 3, which is 2 seconds. So the correct answer in this case, guys, the correct answer in this case is just 2 seconds. If in the first case it takes 9 seconds, and the second case it will be just 2 seconds. Hi Apple Pops, hi Apple Pops, how are you? Thank you so much for being here. I love seeing you guys. I love seeing you guys. Seriously, seriously. So I miss you guys too. Seriously miss you. And let's go back. Okay, let's move on. Let's move on. Apple Pops, welcome to my channel. Okay, yeah, this was simple, but Kadoosh, that's the point. That's the point. From each chapter, simple questions also get into the main advanced level exams. Okay, so it's very important that you also, whenever you are giving the advanced paper, always read the paper. When you read the paper, now you'll always find questions like this, which are very easy. Okay, so do that, do that, do that. Okay, hi Kashish Chawla, it's okay Kashish, I'm so sorry Kashish, I'm so sorry. You can check out other channels from Vedantu Kashish, you can check out other channels of Vedantu, maybe you will find what you like. Okay, now, alright. Varun Shastri, KVPY, please start preparation in 11th. Do not be very hasty, my friend. Do not be very hasty. If you do that, you will get burned up. Okay, right now, focus on short-term goals. Long-term goals, it's nice to have, but still keep your eyes on the ground right now. Keep your feet on the ground, not eyes. Keep your eyes up there. Okay. Abhyuday is scared for class 10th board only. Okay, next is I have this. This is once again a very simple question, but once again an advanced level question. Okay, and this actually came in the advanced. So what is happening is I have two temperatures here. This is at 300 Kelvin, and this is at 200 Kelvin, and I have a junction here which is at temperature of 200 Kelvin. It is at a temperature of 200 Kelvin. Okay, now here we are given certain data. Okay, the radius of the bigger cylinder is twice the smaller cylinder. Okay, so radius of the second one is twice the radius of the first one. Radius of the second one is twice the radius of the first one. Okay, which means that the area of the second one will be 4 times the area of the first one. Why did I say that? Why did I say that? Because you have to remember that area is equal to pi r square. Area is proportional to square of the radius. Now, in this case, you have to find the value of k1 by k2. It's a very simple question. Hi Akhil Nayak. Hi, hey there. Oh my God, Shruti. Hi Shruti. Thank you so much. So how to solve this, guys? How to solve this? So here you have to remember one principle. Okay, here you have to remember one principle, and that principle is that if some amount of heat is transferring from here, the same amount of heat will also transfer from here. Basically, if the current here is H, the heat current here will also be H. Okay, both places the heat current will be same. What I can write is, by the way, let me just write down the temperatures once again. This was 300, this was 200, and this was 100. Okay, what I can write is, if you guys remember, T1 minus T2 is equal to H into R, which gives me H is equal to T1 minus T2 upon R, where this R is supposed to be the thermal resistance. So I can write 300 minus 200 upon L by K1A1 is equal to 200 minus 100 upon L by K28. Both of them have the same length. Okay, if you check this out, guys, a lot of things get cancelled out. L and L gets cancelled out. I just get 100 K1A1, sorry, 100 K1A1 is equal to 100 K2A2, or K1A1 is equal to K2A2. Oh my God, is this question even an advanced level question? Oh my God. Okay, so we have to calculate K1 by K2, correct? We have to calculate K1 by K2, that will be same as A2 by A1. That will be same as A2 by A1. Okay, which if you calculate here, you will see that A2 by A1 is 4. Okay, so you just use that here, which gives you the value 4. Hi, Corey Meher. Hi, Skadush. Skadush also got the same answer. Surender got the same answer. Ujwal got the correct answer. Superb. So proud of you guys. So proud of you. Superb, guys. Superb. Okay, I hope everybody understood, guys. I hope everybody understood. And at this point, let me tell you for 1 minute. Let me tell you about the Vedantu's JEE Advanced crash course. Okay, guys, if you're preparing for JEE 2020 Advanced, okay, then in that case, Vedantu is offering you a crash course which is worth only 1999 right now. You can go to bdnt.in/JEECEE and use that coupon code to enroll in that. Use that coupon code to enroll in that. Alternatively, what you can do is just come here and do 5 questions daily. That's also good practice. Just your if you want good level of practice, Vedantu will make it easy for you because right now, guys, you have to understand practice is the most important thing. Okay, if you join, you will be able to practice a lot of questions. Okay, anyways, so let's talk about the next question. Now, the next question, yeah, this question is very. Oh. This question is very. Uh, it's an easy question, but confusing data, confusing. It's just confusing me with its words. Okay, so what we'll do, guys, is we will try to make a diagram. Okay, so what is happening is that I have a body here, and this body, let's try start making the diagram. Okay, this body is at temperature of 487 degrees Celsius. Okay, and here I have a sensor somewhere around. Okay, I don't know how to make a sensor, so let's just make a sensor like this. I have a not sensor, sensor. Yeah, I have a sensor somewhere around which is measuring the amount of heat coming out of this body. Okay, which is measuring the amount of power coming out of this body. Okay, and when it measures the amount of power P coming out of the body, it doesn't just directly give us the value of P. What it does is it gives us the value of this quantity, this weird little quantity. Okay, what is this weird little quantity called? What is this weird little quantity called? They haven't said. But what they've done is that okay, this sensor gives us the value of this beta. Okay, let's just call it beta for now. This beta is named as log 2 P by P naught. This is the value that the sensor gives us. Okay, now what they have said is that at temperature T is equal to 487 degrees Celsius, the value of beta comes out to be 1. Okay, you have to find beta at temperature T is equal to 2767 degrees Celsius. If the temperature of the body is increased, if the temperature of the body is increased to 2767 degrees Celsius, what will be the measurement of this sensor? Okay, alright, hi Apple Pops, yeah, I'm trying, my friend, I'm trying. Okay, alright, so oh, Shravani Reddy is back here. Shravani, I'm going to put the notes online. Okay, I'm going to put the notes online. Do not worry. Today, I'm putting the notes online. Okay, so how to solve this question, guys? How to solve this question? Here, you have to remember Stephen's law. Okay, here you have to remember Stephen's law. If you remember Stephen's law, guys, what was Stephen's law? Stephen's law said that the heat emitted by any body is going to be equal to Q A sigma, sorry, is equal to E A sigma T raised to the power 4 into delta T. Okay, where E is the emissive power, A is the area, T is the temperature, and delta T is the time. From this, if I take delta T in the other direction, then this gives me the power, heat radiated per unit time. Okay, I hope you guys can see this. Now, basically, the only thing you have to understand from this is that from this we realize that the power radiated by any body is proportional to T raised to the power 4. Just remember this, power radiated by any body is proportional to T raised to the power 4. Now, in this case, guys, I have two different temperatures. One temperature is 487, the other temperature is 2767, and that will give me two different values of beta. Okay, so let's say what I assume is that at temperature T1 is equal to 467, right? 467? No, 487. At temperature 487, the value of beta is beta 1, which is given to us as 1 only. And temperature T2 at 2767 degree Celsius and degree Celsius, by the way. The value of beta is beta 2. Okay, now I know the formula for beta. The formula for beta 2 will be equal to log base 2 power P2 by P naught. And the value of beta 1 will be equal to log base 2 power P1 by P naught. This is what the sensor is measuring. Okay, this is what the sensor is measuring. So if I take the difference between the two guys, what will I get? I will get a weird expression like this: log base 2 P2 by P naught minus log base 2 P1 by P naught. Now, I don't know if you guys have studied log before or not. Okay, but if you have, this expression can be very easily simplified to log base 2 P2 divided by P1. This expression can very easily be simplified to log base 2 P2 by P1. Okay, I hope you guys understood. I hope you guys understood. Really hope you guys understood. Okay, now in the next step, guys, what do we do? In the next step, first let's calculate all these temperatures in Kelvin. The temperature in degree Celsius is 487. So how much will the temperature be in Kelvin? You have to divide, you have to add 273 Kelvin. Okay, when you calculate this, it will be equal to, let me check. Yeah, 487 plus 273. Oh my god, this will be equal to how much kelvins? Oh. This, if you check, guys, it will come out as 760 Kelvin. Okay, if you check, it will come out as 760 Kelvin. I think so. Okay, this P naught, yeah, Shravani Reddy, I don't know if you know this. Okay, this Shravani Reddy has a good doubt, so let's solve Shravani Reddy's doubt. How did I write log 2 P2 by P naught minus log 2 P1 by P1? So Shravani Reddy, there is a formula in log. Log B minus log A can be written as log B by A. Shravani, are you aware of that? Are you aware of that? So from that you can write log 2 P2 minus P naught minus this as equal to log base 2 P2 by P naught divided by P1 by P naught. Okay, now if you have to divide, what you just do is you just invert and multiply. Okay, you just invert and multiply. So into P naught by P1. P naught and P naught gets cancelled out. Okay, alright. So in this case, also I will calculate the temperature of 2767. So this will be equal to 2767 plus 273. That will be 3040 Kelvin. Yeah, 3040 Kelvin. Oh my god, are these convenient numbers or what? Okay, now next thing, guys, you have to remember here is very simple, that power P2 by P1 is going to be T2 raised to the power 4 upon T1 raised to the power 4. Why did I say power P2 by P1 is equal to T2 raised to the power 4 divided by T1 raised to the power 4? Because power is proportional to fourth power of temperature. Power is proportional to fourth power of temperature. Okay, so based on this, I can just write it as 3040 upon 760 raised to the power 4. Now, I don't know if you guys know this, but this is just going to be 4 raised to the power 4, or I can write it as 2 raised to the power 8. Okay, substituting this here, guys, I can write beta 2 minus 1 as equal to log base 2, 2 raised to the power 8. Now, why did I write minus 1? Because beta 1 has a value of 1. If you solve this, beta 2 comes out as 9 very simply. If you understood, guys, give me a thumbs up. If you understood, give me a thumbs up. Thank you, Surendra. Thank you. Hi, Ujjwal. Yes, Ujjwal, your answer is correct. Super proud of you, Ujjwal. Hi, Apple Pops. Hi, Apple Pops. Apple Pops. I will get back to you later. Okay? Don't worry. Now, guys, the hard question for the day. Okay, I was going to put all of the easy questions, but sometimes, in between easy questions, there are going to be hard questions. Okay, super hard question. Okay, next question is not easy. Next question is not easy, and for me to be able to explain to you, you will need to show some patience. Do you have patience, guys? Do you have patience? Will you be able to stay with me till the end of that question? Yes. And if you have any doubts, will you ask me your doubts? If you can do that, then I will do the next question. Okay, it's a hard question, but I will explain it thoroughly and clearly. Okay, I will explain thoroughly and clearly if you stay with me till the end. Okay, you have to stay till the end because it's a hard question. I remember it's because I solved it myself. Okay, I solved all the questions myself, and it requires integration and this and that and so many different concepts just mishmashed together. Okay, so first let me just do this. Okay, let me just duplicate this slide 3 4 times because I will need this. I will need this. I got it. I duplicated that slide 3 4 times because that is where I'm going to write. So first let's read this question. Okay, and I will make diagram as I have. So I have two wires PQ and RS and they are joined at the ends Q and R. So I have two wires. One wire is PQ and the second wire is RS and they are joined at these ends. Okay, they are joined at this end. Q and R end joined together. Now, initially each wire has a length of 1 meter and 1 meter. Initially each wire has a length of 1 meter and 1 meter. Okay, I'll just underline this here because it's distracting me in the diagram. So initially each wire has a length of 1 meter and it's at temperature of 10 degrees Celsius. But this is a waste data, it doesn't matter. Now what happens is that the end P is maintained at 10 degrees Celsius. So this end, guys, I am going to maintain at 10 degrees Celsius. And the end S is heated and maintained at 400 degrees Celsius. So this end I am going to maintain at 400 degrees Celsius. I hope you guys understood. Really hope you guys understood. Okay. Now, in this case, guys, in this case, what do I have to do? What do I have to do? Okay, you have to. Now, the system is thermally insulated from the surroundings, whatever. Now, other data is also given. Thermal conductivity of PQ is twice the thermal conductivity of RS. Thermal conductivity of PQ is twice the thermal conductivity of RS. What this means is that if this wire has thermal conductivity 2K, then this wire just has thermal conductivity K. Okay, and we are given coefficient of linear expansion of PQ. We are given coefficient of linear expansion of PQ. Now, if I am putting this entire system in this fashion, then you have to find the change in length of the wire PQ. You have to find the change in length of the wire PQ. Guys, I hope you guys understood the question. Okay, guys, I hope everybody understood the question. If you did, superb. Welcome, Darth Vader is here. Okay, if you understood the question, guys, superb. You just need to know how to solve this now. Okay, I hope whoever is here understood the question. Okay, now how do we solve this question, guys? How do we solve this question? So in this case you need to remember a few things. The first thing you need to know is the junction temperature. First thing you need to know is the junction temperature. Okay, how do you know? How do you hi Suraj, hi, welcome to this question. It's a tough question, Suraj. We are going to solve it using integration and all. I hope you understand. Okay. So if you have a junction temperature, how do you calculate that junction temperature? Okay. So first, let's assume that the heat is flowing in this direction. Why am I saying that the heat is going to flow in this direction? Because heat always flows from higher temperature to lower temperature. Heat always flows from higher temperature to lower temperature. I hope you guys are following so far. Okay, one second. I hope everybody is following. I hope everybody is following. If you are following, then let's do this. What I can do is I can make this diagram here. Okay, let's copy this diagram. Yeah. So what I can say next is this. What I can say next is this, that the heat current through RS is the same as the heat current through PQ. Okay, junction temperature. Yeah. Okay, hi Suraj. So how do we calculate the junction temperature? What you can say is heat current through PQ is the same as heat current through RS. Okay, if you guys remember, what is the heat current? V is equal to IR, or temperature difference is equal to heat current into resistance. So heat current will be equal to T1 minus T2 upon R. Okay, so what I can write is 400 minus T upon 400 minus T upon L divided by Ka. I did not write this correctly. I did not write this correctly. One second. Huh? I will write for the wire RS 400 minus T upon L divided by Ka is equal to T minus 10 upon L divided by 2Ka. Okay, now if you see here, Ka gets cancelled out. This 2 will go up, and what I will get is 2 into T minus 10 is equal to 400 minus T. Now guys, you can solve this question here. If you solve this, you get 2t minus 20 is equal to 400 minus t. T will be coming out as 140 degrees Celsius. T will be coming out as 140 degrees Celsius. Now, if I have a temperature as 140 degrees Celsius, my problem is still not over. Okay, because if I just look at the wire PQ, okay, let's just look at the wire PQ. Now, if I just look at the wire PQ, I have to find the change in length of wire PQ. The problem is that the temperature at all the points is different. Temperature at all the points is different in this wire. The temperature at this point will be different than temperature at this point, which will be different than temperature that at this point. All the points of temperature is different. So first, I will need to calculate temperature at all the points. First, I will need to calculate temperature at all the points. Let's say I go a distance x from here and assume that the temperature is T at this junction. By the way, what is the total length? What is the total length? 1 meter. Okay. So in this case, what I can say is that the heat current through the entire wire is H, and there is one more formula for H, guys. There is one more formula for H. H is equal to K into A into dt by dx. K into A into dt by dx. Okay, what is K here? Conductivity A is area, and dt by dx is the rate at which temperature changes with this. Now, in this case, there's a minus sign here as well to give you the direction. But in this case, if you see, H is a constant, K and A are also constant, which gives that this should be constant. Should be constant. Okay, for the entire wire, the dt by dx should be constant. What that essentially means is that the temperature change divided by the length of the entire wire will be same as the temperature change divided by the length of the small part. The temperature change divided by length for this region will be same as the temperature change divided by length for this region. Okay, so from this, guys, from this, I finally get the temperature at distance x. What I do is I cross multiply, I get t minus x is equal, t minus 10 is equal to x into 130, or t is equal to 10 plus 130x. T is equal to 10 plus 130x. This is temperature as a function of distance. This is temperature as a function of distance. Okay. Now, after I solve this question, now guys, I will give you one more shortcut. Okay, after I solve this question, I'll give you one more shortcut, but you have to stay till the end. You have to stay till the end, then I will tell you the shortcut. Okay, you have to stay till the end. You have to stay till the end. Okay, I will tell you a shortcut for this question. Anyways, for this, now what I do is I will take a small element here of length dx. Okay, now this element is not very small, but I have made it big because you can see it. Now what happens is, now this is where this data becomes important. Initially, guys, that element was at a temperature of 10 degrees Celsius. Initially, that element was at a temperature of 10 degrees Celsius. Now that element has a temperature of T. So because of increase in this temperature, what will happen is, because of increase in this temperature, this small element will experience an increase in length. This is increase in length of just that small element. Okay, let's call that increase in length as dy. Let's call that increase in length as dy. This is the increase in length of that small element. Okay, what I do is, if you remember, for a wire, you can write the change in length upon the original length is equal to alpha into change in temperature. The change in length upon the original length is equal to alpha into change in temperature. Now, now, if I just consider that small element, guys, what is the change in length for that small element? For that small element, the change in length is dy. And for that small element, what is the original length? Dx. And alpha is a constant. What is the change in temperature for that small element? So if you see, that small element had initial temperature of 10 degrees Celsius and now it has a temperature of T. So its change in temperature will just be T minus T. Okay, now substituting the value of t, guys, you get dy by dx is equal to alpha into, if you do t minus 10, only 130x remains. Only 130x remains. Okay, I hope you guys can see this. I hope everybody can see this. I hope everybody can see this. Okay, now from this, guys, oh, what I can say is that dy is equal to 130 alpha x dx. Now, if I integrate this, then I have to substitute the limits for x. The total length of the wire is 1 meter, so x will go from 0 to 1, which gives me y is equal to 130 alpha into x square by 2 from 0 to 1, or y is equal to 65 into alpha. Y is equal to 65 into alpha. Now, if you know what is alpha, alpha is 1.2 into 10 power minus 5. Okay, so this will become 78 into 10 power minus 5 meters, which is 0.78 millimeters. Okay, now what does this mean, guys? If you see, dy was increase in length of the small element, so y will be total increase in the length of the wire. Y will be the total increase in the length of the wire. Okay, I hope everybody understood. Balram is saying, sir, मेरे से thermal physics पढ़ा but advanced level के IIT questions नहीं हो रहे. Balram, send me those questions on my Telegram AADITYAP 832. Okay, and let me try to help you solve this questions. Okay, first time लगाने पे बलराम थोड़ा सा problem आता ही है, so come and send me those doubts, I will help you. Okay, all right. So yeah, this was the long cut method, guys. This was a long cut method. What is the shortcut method? What is the shortcut method? Okay, so shortcut method is very simple. If you see, finally I have a rod which is 10 degrees Celsius on one side and 140 degrees Celsius on the other side. Okay, now if I ask you what will be the average temperature of this rod, what will be the average temperature of this rod? The average temperature of this rod will be 10 plus 140 divided by 2, that will be 75 degrees Celsius. Okay, this is the overall average temperature of this entire rod, and I can write delta L by L is equal to alpha delta T. So I can write change in length upon the original length is equal to alpha into final temperature minus initial temperature. Final temperature minus initial temperature, which gives me the change in length as 65 alpha, that is same as 0.78 millimeters. Okay, you can just take average temperature and get the answer very simply. You don't need to do all of this. Okay, you don't need to do all of this. You can just take average temperature and still get the answer. I hope everybody understood. Varun Shastri is back. Varun Shastri is back. Okay, I hope guys, you guys understood. I hope everybody understood. Really hope everybody understood. Okay, next is one last question for today. But before we do that, once again, let's talk about Vedantu's JEE Advanced Crash Course, guys. If you want to practice a lot in the end days of your advanced preparation, then you can do that by getting into our JEE Advanced Crash Course. It just costs 1,999, and you will get a lot of practice while doing the crash course. If you want to apply for it, you can do it by going on to vdnt.in/JECCE and using my coupon code AAPCC. Okay, so if you want to do that, you can check it out right now. Okay, next, last question, guys. Hi, Nikhil Singh. Hi, Varun Shastri is also back. Okay, guys, let's do the last question. Okay, last question is a radiation question, and it's a very easy question. I'll give you 1 minute to just read the question. The problem with physics is the questions are very big, especially the advanced questions, super duper big. So let's just focus some time on just yeah, I know Ujjwal Agarwal, I know Doi then Pache. So that's why, but if you just want to practice, you can enroll. Otherwise, it's just practice at home, practice at home, practice at home. Okay. Mhm. Alright, so I have two spherical stars, okay, which emit black body radiation. The radius of A is 400 times that of P, and it emits 10 power 4 times the power that of P. Okay, if the ratio of lambda A by lambda E for the peak emission are this, then you have to find the ratio of their peak emission wavelengths. You have to find the ratio of their peak emission wavelengths. So let's just start by making the diagram. Let's say I have one star of radius A and another star radius B. Okay, one of them has 400 times the radius than the other. The radius of A is 400 times the radius of B. Okay, and let's say the temperature of A is TA and the temperature of B is TB. What they have said is that the power emitted by A is 10 raised to the power 4 times the power emitted by B. What this means is that if B emits P power, then A will emit 10 raised to the power 4 P power. Power of A will be 10 raised to the power 4P. Okay, in this case, you have to find lambda A divided by lambda P. Now, guys, for this, you have to remember that power emitted by a star is equal to EA sigma T raised to the power 4. Okay, which gives me power of A divided by power of B as A sigma T A raised to the power 4 divided by B sigma T raised to the power 4 TB raised to the power 4. Okay, now if you do PA by PP, if you see PA is 10 raised to the power 4P, PB is just P, PA by PB will just be 10 raised to the power 4. That is going to be equal to, area की बात करें तो area of A will be equal to 4 into pi into 400 R the whole square, and area of B will be equal to 4 into pi into R the whole square. Okay, so that will be equal to 400 R the whole square divided by R the whole square into TA by TB raised to the power. TA by TB raised to the power 4. Okay, now if you see from here, I get TA by TB raised to the power 4, guys, is equal to 10 raised to the power 4 divided by 400 whole square. Okay, which gives me TA by TB is equal to, oh my god, 18234 divided by 16 1234 raised to the power 4. Okay, which gives me TA by TB as just equal to 1 by 2. TA by TB is just equal to 1 by 2. Now TA by TB is 1 by 2. Hi Jatinder. Hi. Hey there. If which Vedantu pack do I take to learn physics from you? Hey there. I am not teaching physics in class 11th at the moment. I'm only teaching physics in class 10th on class 12th on Vedantu platform. Okay, only 12th. But if you want to check out all the Vedantu faculties are good, my friend, you should take a trial period and see if it works out for you. Okay, you should take a trial period and see if it works out for you. Now in this case you have to remember Maxwell's not Maxwell's Wien's displacement law. Lambda a into t is equal to constant. Okay, lambda b into t is also equal to constant, which gives me, this is Wien's constant, which gives me lambda a by lambda a t a is equal to lambda b t b. Okay, which if you solve gives you lambda a by lambda b as equal to TB by TA, which will be equal to 2. So the correct answer for this question, my friends, is going to be 2. Okay, correct answer will be 2. Hi, Apple Pops. Hi, hey there. Okay, I hope everybody understood. Okay, I hope everybody understood. So guys, those were the 5 advanced level questions from thermal physics, 5 advanced level questions from thermal physics. Tomorrow we are going to do one other chapter from class 11th only, or no, tomorrow we are going to do 5 advanced level questions from electromagnetic induction. Okay, so if you want to check that out, come there. Also at the same time, if you haven't subscribed to our Telegram group, you should do that. I'm going to share the notes of these lectures and other assignments on that group. Okay, so that's it, guys. That's it for today. That's it for today. Thank you so much for being here. Come here again, and I will see you guys tomorrow. Okay, have a nice day. Bye bye. Bye.